Today we'll be working on vertical asymptotes with rational functions. As you can see, the vertical line x equals c is a vertical asymptote of the rational function f of x if, as f of x approaches positive or negative infinity as x approaches c. Now what that means is if you have a graph, and we know 1 over x squared parent function has asymptotes at x equals 0 and y equals 0. Now if you look at x equals 0, we see that vertical line. Okay, now as f of x approaches positive infinity, as the graph is going up to that positive infinity value, our x is coming to our c value, and that c will be 0. So x is approaching 0 as y is approaching positive infinity, thus creating a vertical asymptote at x equals 0. Vertical asymptotes have to deal with the domain of our functions. So let's look at an example. We are learning about vertical asymptotes with rational functions today. Now what this says is the vertical line x equals c is a vertical asymptote of the rational function f of x if, as f of x approaches positive or negative infinity as x approaches c. To see this in a function, let's look at the parent function f of x equals 1 over x squared. So if we do a quick sketch of the graph of this function, we can see our vertical asymptote here at x equals 0. Now, if we look, as the function of x approaches positive or negative infinity. So here it's approaching positive infinity. As the function approaches positive infinity, our x will approach 0. X approaches the c, or in this case, 0. Therefore, the vertical asymptote of this parent function, f of x equals 1 over x squared, is x equals 0. So when we're looking at vertical asymptotes, we want to look at the domain of the function. So here, our domain, all real numbers, such that x cannot equal, and so here we look at the denominator to see what x cannot equal. So we know the denominator cannot equal 0. So therefore x cannot equal 7. So in our domain, all real numbers such that x cannot equal 7. Therefore, our vertical asymptote for this function, x plus 2 over x minus 7, will be at x equals 7. Let's look at another example. Here we have f of x equals 3 over x squared minus 1. When we look at the denominator and see when that will equal 0, if we add 1 to both sides, we get x squared equals 1. Take the square root of 1. Whenever we take the square root, we have to do plus or minus. Square root of 1 equals 1, so x equals positive or negative 1. Therefore, our vertical asymptotes for this function will be when x equals positive or negative 1. Let's look at our last example for vertical asymptotes. We have the function f of x equals 3x squared minus 4x plus 3 over 7. Looking at the domain of this function, we see that it is all real numbers. We look at the denominator, and this will never equal 0. It is a number, so it can never be 0. So therefore, domain is all real numbers. There are no vertical asymptotes for this function.